My name is Tim Ronan, and I'm an alumni from Boise State University. I graduated with a Bachelor's of Science in Geophysics. Currently, I'm a master's degree student at University of North Carolina. I decided that I liked Boise State so much that I wanted to figure out a way to come back and work with some of my old advisors and in my old department. So I convinced my current advisor, Dr. Jonathan Lees, to help me come up with a different idea where we could try to discover how whitewater features produce infrasound or acoustic signatures and also seismic signatures. The reason that we're at the Boise Whitewater Park is because at the Boise Whitewater Park we can change how the wave is behaving or how the wave is vibrating, and so we can see how these respond in our instruments. We want to get the depth of the wave with the avalanche probe, and I have to swim to get that depth, and the velocity with the oranges, and we're going to relate those to the energy signature that is being shown in our seismic and acoustic instruments. So surfers like riding on waves that are generally faster and shallower. In the surf world, we call that a green wave. Kayakers like waves that are deeper and are slower, and in the kayak world we call that a hull. And the difference between the green wave and the hull can show up on our instruments. So by figuring out these different responses on our instruments, eventually we can go backwards and we can engineer a way to make it so we can automatically change how the wave is behaving depending on its signature.
My name is Dr. Jeffrey Johnson, and I'm a professor in the geophysics program at Boise State University in the Department of Geosciences. This project at the Boise River is being led by my former student, Tim Ronan, and I'm really proud of the work that he's been doing. Now, this project is entirely the design of Tim Ronan. So he's come up with an idea, a testable hypothesis, to relate water flow in shape of waves to earthquakes that are propagated through the ground to seismometers, and sound waves that are low frequency and that are recorded with specialized microphones. And at the same time, he's engaged Boise Department of Recreation to alter the shape of the waves and relate these wave shapes to the physics of the seismic and the infrasound.
My name's Dylan Mikesell. I'm an assistant professor in the Geosciences Department at Boise State University, and I'm working with Tim on this project, helping to guide him through the seismic aspect of his data. So he's measuring waves in the air and waves in the earth. I specialize in the waves in the earth. Dr. Johnson specializes in the waves in the air. And with the two of us and Tim's advisor back at UNC, he has a pretty good group of advisors to help him solve his whitewater problem.
In the whitewater world, we talk about looking at the river and determining how the river's behaving as reading the river. And essentially what we're doing is we're reading the river with seismometers and microphones. But this is finally a way that we can take this information and give it to the general public without having to have 10 years of experience to really understand how these rivers are behaving.
The work that Tim is doing is inspired by Tim's love and passion for kayaking, but what he is doing is intensely theoretical and complex. And he's trying to illuminate processes that occur in river systems that can be applied to other rivers elsewhere. The tools that he is utilizing and analyzing will allow us to have capabilities to measure stream flow in river systems where we're interested in floods, not just the shape of a wave for kayakers, but there's broader impacts to Tim's research which are very important.
We definitely want to thank the City of Boise Parks and Recreation for volunteering us time, man hours, and shutting down the whitewater feature for us to do this experimentation. The environmental and ethical impacts of this are huge for me, and I really hope that we can find a way to better shape these waves to give back to the whitewater community, which I'm part of and I care very much about.